Good day and welcome to my YouTube channel. I am Arthur Francis Devan. Welcome to AFD'S Academy. In our last class, we discussed about cations, which are positively charged ions, and the color which they exude when we use sodium hydroxide solution and ammonia hydroxide, which is ammonia and water. So as the major reagent, we were able to see the changes that exist between them, where with sodium hydroxide we have a peculiar color, and when we confirm that with ammonia, we also have some distinct colors, sometimes different, sometimes the same, but the solubility are not the same. So in all things, it is pertinent that today we have to go through the anions, which are the negatively charged ions, the reactions, the tests, the observations, and the inferences which they undergo with certain reagent. So I tried to explain last time when I say sample A plus sodium hydroxide. A lot of us will be asking questions like, what is sample A? I don't know if you understand. I'm trying to explain that to the best which I could. Now, if presumably sample A is sodium chloride. Now, that sodium chloride will be taken in a test tube. All right, like I said, if presumably sample A is sodium chloride and you are given instructions as sample A plus sodium hydroxide gives you what? Or sample A plus ammonia solution gives you what? But today, since we are dealing with anions, we are dealing with different what? Reagents. For example, we are going to test for sulfate, SO4, and 2 minus, SO3, 2 minus. If we're to be dealing with anything that has to do with sulfate, and you are asked to say, add sample A with a little distilled water, sample A plus barium chloride, what do you get? We say you have a white precipitate, okay? Then that solution of that sample A plus aqueous hydrochloric acid, which is dilute hydrochloric acid, what do you get? Does the precipitate dissolve or not? So I just want to give us a little an overview of that reaction, what it will look like. Let's assume this is my test tube and this is sample A. I don't know what it is and you don't know what it is. It is based on the reactions that you'll be able to define or tell us what sample A is based on what you're going to get. So I take a little of sample A, which is this, put it in my test tube. So you and I don't know what this is yet, and I have it covered. And with my water, distilled water, a little of it in there, I homogenize it till it dissolves. If you look, you see it has dissolved. Okay, now this is now sample A. When we say sample A plus barium chloride, when you add barium chloride to this, there is a reaction. The color will change. So your ability to understand the change in color from this to whatever it gives you, you'll be able to predict that it is barium. Either you're testing for sulfate or you're testing for chlorine, you're testing for iodine, bromine, sulfite, and so on. That is how it is. So I will give us an overview. I want you to have a basic or a fundamental understanding when you are in the lab or you are being instructed that sample A plus this. Do not forget that sample A must be in aqueous form, which means that a little distilled water must be added first to it to homogenize before you add whatsoever the reagent you'll be instructed to add. So now we understand what sample A is, or sample B is, or sample whatever it is that you will be asked to deal with. So let us get to the basics of today's work. So our first test will be test for sulfate ion, SO4. So how do we test for this? A sample will be given to you just like this. A sample will be given to you which you don't know. It will be labeled sample, whatever it is. I'll ask you, or you'll be asked, sample A plus barium chloride. That is your test. In the test, sample A plus barium chloride, for example, A plus barium chloride. Now, when you do this, we say we have a white precipitate. You have to write it in full, don't abbreviate. Because of space, I have to manage this. White precipitate is formed. Now, what are the other anions that have white precipitate? We say SO4 2 minus, SO3 2 minus, X 2 minus, etc. are probably what? Present. Even CO3 2 minus. These guys are probably present because all of them will give us white precipitate. But remember, what we are looking for is SO4. Now, we will now have to look at distinct characteristics that will tell us that it is SO4 and not SO3 or not S2 minus or not CO3. So, this white precipitate will now say A, solution A plus dilute hydrochloric acid in SS. Now, when I dilute hydrochloric acid to that solution which I have formed, I will have the white precipitate insoluble in SS dilute hydrochloric acid. Then I will come here and say SO4 2 minus confirm. Let me explain that a little bit again so that we'll get it. You will be in a lab with various reagents kept, labeled to be whatever they are. And you will be instructed that sample A plus barium chloride, you don't know what you're testing for until you begin to see the observations that are coming forward. It is from the observation that you'll be able to predict, to tell us that it is this or it is that. So now, when we do that, we have white precipitate is formed. Now, that white precipitate could be as a result of the presence of SO4 or SO3 or CO3 or S2 minus. These guys all exude what? White precipitate. Now, I have to carry out the second instruction says solution of 1 above plus dilute hydrochloric acid. Now, when I add dilute hydrochloric acid to this, that white precipitate remains what? Insoluble in excess dilute hydrochloric acid, which tells you that it is SO4. Why is it SO4? Because SO3 would have been soluble with dilute hydrochloric acid. CO3 would have been soluble with dilute hydrochloric acid. So, but we know that SO4 is insoluble in dilute hydrochloric acid. So, as soon as we have white precipitate insoluble in excess dilute hydrochloric acid, we have to come to the conclusion that SO4 is confirmed because it is only this guy that will not be soluble in excess what? Dilute hydrochloric acid. So we are going to take the triazosulfate 4 ion, which is SO3. So we'll begin to look at the differences that will emanate from there. Let's take another one. With SO3 2 minus. For us to test for the presence of the triazosulfate 4 ion, the principles are similar. We will say if that sample, because I've given you the salt, I label it sample A or sample X. You do not know what that is. Now, that sample which I have given to you, let me call it sample X. I will now say X plus barium chloride. We now have white precipitate form. Now, we still have white precipitate. Our mind will still go back to this particular anions, SO4 2 minus, SO3 2 minus, CO3 2 minus, S2 minus are probably present. Now, the second step is the solution that gave us this white precipitate. We say solution plus dilute hydrochloric acid in excess. We say white precipitate dissolves in excess dilute hydrochloric acid. Now, because it dissolves in excess dilute hydrochloric acid, it streamlines our inferences to be SO32 minus CO32 minus probably present. Now, these two anions are soluble in excess dilute hydrochloric acid. We need to carry out a top test to confirm whether it is this or this. But now you know that this is the guy we're looking for because I've written it here. So you have an idea already. So by the time you begin to see the observations and the inferences, your mind should go straight to know what exactly you should be expecting. So now, this is what we are having. We now say from this solution, we are going to acidify it with solution above plus dilute H2SO4 tetraoxosulfate acid followed by KNNO4 potassium tetraoxomanganate 7. So when we add this, we know the color of KMNO4 is purple. Obviously, having added this, it will become purple in color. That is it. But because of the presence of SO3, it will give us something else. Now, once we add this KMNO4, which is purple, but with the acidified system, that purple color of KMNO4 becomes decolorized. We say purple color of KMNO4 is decolorized. And when that happens, we say SO32 minus is confirmed. Now, we must know the difference in what we are dealing with. The first one, we are testing for sulfate. When we added barium chloride, we have the white precipitate form. We have these various inferences that give us white precipitate. So we did not know which one was there until we added dilute hydrochloric acid. In dilute hydrochloric acid, that of SO4 was insoluble. But now, in that of SO3, the white precipitate dissolves in excess dilute hydrochloric acid and it streams down our inference to SO3 and CO3. Then we use dilute hydrochloric tetraoxosulfate acid with KMNO4. Now, when we did that, the purple color of the KMNO4 becomes decolorized. When that happens, our mind now goes that it is SO32 minus confirmed. So that is test for SO3 triazosulfate 4 ion. So we're going to take another one. We're going to take CO3. This. CO3 2 minus. In test for carbonate, we say sample X plus dilute hydrochloric acid. When we add acid to a carbonated compound, we say there is a gas, effervescence was given off, a gas was given off, and when we test that the gas with blue litmus paper, it turns the blue litmus paper red, which means that gas is an acidic gas, number one. And when we pass the gas in lime water, it turns the lime water milky. And the gas obviously is CO2 from a carbonated solid. So a gas was given off, which turns blue litmus paper red and turns lime water murky. We say the gas is acidic. And not just the fact that the gas is acidic, two, because it turns blue litmus paper red, it shows an acidic property. Two, it turns lime water murky. The gas is carbonate, CO2. The gas is acidic, which is CO2 gas from a carbonated salt. It's obviously what CO2 from a carbonated salt, which could be CO3 2 minus or HCO3. So it could be from any of these. Provided this is being used, you will get what? A gas. CO2 is an acid anhydride. An acid anhydride, which is an oxide of a non-metal. If you dissolve it in water, you form a carbonate, a carbonated acid, H2CO3. If I add, this is CO2 plus H2O will give us H2CO3. This is an acid. It will form an acid. So obviously that gas comes from a carbonated compound. So that is it for our CO3. Let's take another one. Let's check for nitrate. NO3 minus. We call it sample X. In sample X, we want to check for the presence of nitrate, which gradually we will follow the steps. Sample X plus freshly prepared iron 2 tetrazosulfate 6. Now we are going to add sample X plus freshly prepared iron 2 tetrazosulfate 6 in the test tube. So if this is my test tube, I have added my sample X here, make a solution. I have to prepare iron 2 tetrazosulfate 6 freshly and add to it. Now, why do we have to carry out freshly prepared? Is because if you prepare iron 2 tetrazosulfate 6 and keep, maybe for a later time to be used, the iron 2 will be oxidized to iron 3. The greenish color will disappear to become brown. So that is gone unless you have to try the other principles to recover it. All right? But now, for the sake of the experiment, we always use freshly prepared, which means the salt is present in the lab. We prepare it there, we use it, and we check for what we're looking for immediately. So this is my sample X. I've added my sample X with a little water and add freshly prepared iron 2 tetrazosulfate 6. Then you slant the test tube a little bit. When we slant the test tube, we add concentrated tetrazosulfate 6 acid down the walls of the test tube gradually, and we ensure that it doesn't mix. And when that happens to the base, to the solution, a brown ring is formed at the junction between the two liquids. Because now we're having a solution that has freshly prepared iron 2 in it. Then before we add our concentrated tetrazosulfate 6, that brown ring will be formed between the interface of the two solutions. And when that happens, that is the observation. We say a brown ring is formed at the junction of the two solutions, and we say NO3 minus is confirmed. So for the test for nitrate, it is simple and straightforward. It doesn't require much. We all understand that our sample is in the test tube, and we add our freshly prepared ion 2 tetrasulfate 6 acid inside the walls of the test tube. We slant the test tube a little bit and add concentrated tetrasulfate 6 acid in drops carefully, because it's very corrosive, so that it wouldn't burn you. Carefully down the walls of the test tube. And when that happens, there will be a brown ring that will be formed between the interface of the two solutions. And when that we see that, we say NO3 minus is confirmed. Let's move on to chlorine, test for chlorine. Now, test for chlorine. In test for chlorine, the same principles are applied, but different reagent. Let's say the sample is sodium chloride, which is our salt that contains chlorine. And we want to test for the presence of chlorine in that sample, which is the reagent who are meant to react with the anion, which is the chlorine, and not touch the sodium. Remember that. So that salt is being added in my test tube. I made a solution of it. Then I come back here, I say sample Y plus silver nitrate. Silver nitrate is the reagent that will be used. When I add my silver nitrate, I'll have a white precipitate is formed. Now, when that white precipitate is formed, the next step will be, okay, let me just write it. White precipitate formed. I will have chlorine, gives me white. I have S, 2 minus, give me white, SO3. All of these probably present. Now, this white precipitate, solution above plus HNO3, triazonitrate 5, aqueous triazonitrate 5 acid. White PPT insoluble in aqueous HNO3. I'll say chlorine ion confirmed. Now, it is still insoluble. Then I'll proceed further to this solution which is insoluble, to the white precipitate or solution above, plus aqueous ammonia, NH3. When ammonia is now added to this solution now, which is still insoluble, they will now have the white precipitate dissolves in excess ammonia. We say chlorine negative is further confirmed. So this is just a 3-step process. It's straightforward if you remember the reagent and the principles. So you know, when once you are testing for chlorine, you're going to be making use of silver nitrate. This thing should come to mind. As soon as you see a silver nitrate, add silver nitrate to a sample, whatever, your mind should take you closer to chlorine being tested. Alright? Now, remember when we were testing for sulfate, what were we using? Barium chloride first, before hydrochloric acid. This time around, we're using silver nitrate first, before triazonitrate 5. And when that happened, we have still the white precipitate remain insoluble until we added aqueous ammonia in excess. Then the white precipitate dissolves in excess of ammonia. And we say chlorine is further confirmed. So we're going to look at bromine and iodine so that we'll be able to see the difference that exists between chlorine, because these guys, bromine, chlorine, iodine, are all halogens. They have similarities in the process or the principles of carrying out what they test. So chlorine, bromine, and iodine will all deal with silver nitrate, and their colors are different. So we're going to see the color that exudes in all of them and the difference between one and another. So we are done with chlorine, but though at the end of the day we're still going to go through like a revised principle to see and compare the differences. If possible, with an assignment to see if you will be able to understand what we're dealing with. So let's deal with bromine this time around. Okay, for bromine, we say sample Z plus silver nitrate solution. Now, when we added this in terms of chlorine, we have white precipitate. Now we have pale yellow precipitate is formed. We say bromine is probably present. That's one. Now this pale yellow precipitate, when we add it, let's call it solution above plus aqueous HNO3. When we add this, the pale yellow precipitate remains insoluble in excess HNO3. Bromine is present. Now, it remains insoluble. Now, when we add ammonia to this solution that remains insoluble, now, solution above plus ammonia in excess or excess ammonia, then we say the pale yellow precipitate becomes partially soluble. That pale yellow precipitate, when we add ammonia, becomes partially soluble, and we will now say bromine anion is confirmed. Now, let us contrast quickly. In terms of chlorine, we have white precipitate. Here we have pale yellow precipitate. Now, when we add, the both of them were insoluble. When we add HNO3, the white precipitate of chlorine remains insoluble, and the pale yellow precipitate of bromine remains insoluble. But when we add aqueous ammonia, the white precipitate of chlorine becomes soluble, and that of bromine becomes what? Partially soluble. So that is the difference. We know that in terms of chlorine and bromine, one becomes soluble, one becomes what? Partially soluble, and the color of chlorine was white, that of bromine is pale yellow. So let us look at iodine quickly to complete the halogens. Okay, that's for iodine. We say sample A plus silver nitrate solution. We have a yellow precipitate is formed. That of bromine was pale yellow. Iodine is just yellow precipitate is formed. And we say iodine is probably present. Then the next thing is we are going to add it with how do you call it? We add it with transonitric acid. So solution above plus HNO3, the yellow precipitate, yellow PPT remains insoluble in excess HNO3. We say iodine is still present. Now, when we add ammonia from that solution plus ammonia NH3, the yellow PPT, permit me because of the yellow PPT remains insoluble in excess ammonia solution. And we say iodine is confirmed. So we've been able to see what happens when we test for anions. The test for anions is significant. It's important, so we don't joke with it. Just like we've carried out the test for cations, we've been able to see the changes that exist in when we use sodium hydroxide and we use ammonia solution. We saw that the test for zinc, aluminium, and lead gave us white precipitate with sodium hydroxide, which is soluble in excess of it. But when we reacted that with ammonia solution, only zinc was soluble in excess. Others give us their white precipitate, which were not soluble. So we're able to differentiate all of that. And when we dealt with copper, we say copper 2 in sodium hydroxide was blue gelatinous precipitate, which was insoluble. But when we reacted that with ammonia, that blue gelatinous precipitate becomes soluble to form a deep blue solution. So we saw this; those are the two unique differences that existed. Meanwhile, calcium, which gave us dirty white, there in sodium hydroxide, in ammonia, there was no reaction. So we know that. And those are basic principles that we don't forget. So these things, we must put them in our head. We must try to remember all the time. So whenever you hear of white, your mind goes to zinc, aluminum, and lead, and calcium, which is dirty white, and so on. Copper is blue, iron 2 is green, iron 3 is reddish brown, and so on and so forth. But that is that about the cations. For the anions, I've been able to give us distinct similarities that exist between especially the halogens and the sulfate and triazosulfate 4, SO4 and SO3. We've been able to see that for the test for SO4, we use the sample plus barium chloride, we got a white precipitate is formed. Having gotten the white precipitate, our mind went to the inference could be SO3 minus, 2 minus, SO4 2 minus, X 2 minus, and so on and so even CO3 2 minus could be probably what present. Then we have to add dilute hydrochloric acid. For the SO4, it is insoluble in excess dilute hydrochloric acid. We knew that it was SO4 present. But for the SO3, that white precipitate which was insoluble becomes what? Soluble. If it is soluble, our mind, we got it streamlined to CO3 2 minus and SO3 2 minus. In order for us to differentiate whether it is SO3 or CO3, we have to add acidify the solution and add KMNO4. Now, the purple color of the KMNO4 becomes decolorized. That tells us that it is SO3 2 minus, and we confirmed it. We say SO3 2 minus, confirmed. This is straightforward. But how do we test for the carbonate CO3? We added hydrochloric acid. There was a gas given on which turned blue litmus paper are red and turns lime water milky. We say the gas is CO2 from a carbonated salt. Is it not? Now, if we are to confirm that further, we can now react that solution with phenolphthalein. It will give us a brick red precipitate. And we confirm it to say CO3 2 minus is confirmed. Bromine, iodine, and chlorine. For chlorine, we reacted it with a white, we reacted with silver nitrate, and we got our white precipitate. We say chlorine, S2 minus, CO3 could be present, probably present. When we move further, we reacted with triazonitrified acid, aqueous. The white precipitate remains insoluble. We say chlorine is confirmed. And we have to further the reaction with what? Aqueous ammonia in essence. And the white precipitate becomes soluble, and we further confirm chlorine. But for bromine, it gave us a pale yellow precipitate when we reacted that sample with what? Silver nitrate. Pale yellow, we say bromine is probably present, and we proceeded further by reacting it again with what? Triazonitrified acid, aqueous of it, and the pale yellow precipitate remains still insoluble. We proceeded to still confirm what? That it is bromine. And lastly, we reacted that with what? Aqueous ammonium hydroxide, which is ammonia solution in water. And the pale yellow precipitate becomes partially what? Soluble. And we say bromine is confirmed because of the partial solubility. Why? That is because iodine, which gives us a yellow precipitate, we reacted it with triazonitrified acid, it is still insoluble. Even with ammonia solution, it remains insoluble. The pale yellow precipitate remains insoluble. So we could make the distinction between iodine and bromine. Bromine becomes partially soluble when ammonia solution was added to it, and bromine remains what? Insoluble. With these distinct features, we can easily comprehend when such an experiment is given to you, sample A plus this, sample B plus this, your mind goes straight to what it should become, and you do not need to doubt it for a second what it should be. Especially when you're beginning to see the reagent therein, you can easily detect or define. I don't need to check or carry any further reactions. If I see sample A plus silver nitrate, my mind goes straight up to tell me a white precipitate could be formed. Now, that is my first impression that comes to mind. But if it is not chlorine, you have to look at the word inference. Is chlorine there? If it is not there, you see bromine, then you know that it is not white precipitate, it is pale yellow precipitate. This thing is simple. So I'm going to give us just one question as, how do they call it? Assignment. You just go through it. Let's see if you understand this principle, this basic simple principle which I've given to us, and see whether we can put it well when it is required. Okay. Let's say A plus this is sample A plus this. You have to fill this. I don't know what this is, but I now have yellow PPT is okay. No. You're going to put the observation. I said bromine is probably present. Now, if this were to be examined, you see sample A plus this, and this space is empty. You are meant to fill the empty space, and you see what here they say bromine is probably present. Your mind should go to what the observation for the test for bromine, and you'll be able to put that. So that's number one. Number two, we say, okay, this is 1. This is 2I. Sample A plus, okay, sample A, let's go back, okay, plus barium chloride. And I have YPPT form. You have to fill this 2II solution above plus dilute HCl. I have CO3 2 minus or SO3 2 minus probably present. You have to fill this space. Now, if that happens, what would be the test? A further test, III. What would be the further test, III, if we have the purple color of KNNO4 is decolorized? And what would be the inference? So this table is giving us an insight of the manner in which questions can be asked. If you understand what I have said today, you can easily understand the principles, what to fill here, and here. So your assignment now is to fill these spaces. So let me call them A, B, C, D, and E. So your job right now is to send the solution to A, B, C, D, and E to my channel. Go to the comment section, you text this solution of this to it. And when I look through it, I will know whether you're right or you're not. Then, I don't know, maybe I should just leave it 1 and 2. But otherwise, I would have loved to add one more. Okay, let me take the last one. 3. A plus okay, plus sodium hydroxide. This is 3I. We have no reaction. Now, this sample plus heating, okay, yeah, plus heating, no, first, that sample plus this solution above plus con HCl plus heating. When we heat it, what happened here? And we say NH3 from an ammonium salt. Ammonium salt probably present. So you have to tell me this is A, B, C, D, E, F, and G. So you have to tell me this. So the manner in which you see it here, that is the manner which you see it in exams. Questions will be asked in this manner. I ask you to fill the table, and when you do that successfully, you do not have a problem. So once again, most of us, I remember, we have not subscribed. And you're basically going to be losing a whole lot if you do not subscribe, because videos like this, you cannot get them easily. And if you have subscribed, you on your notification bell. Whenever I make an upload, you're going to get it. So I will encourage you to subscribe and press the subscription button and the notification bell, that you'll be privileged to get all the good tidings which will be coming forth to you. I look forward that you will be able to go through what we've done today religiously, carefully, and study them in a technical way to understand the basic principles, so that when you get into the class and these things are given to you, you don't need to ask questions because they become part of you. So all you need to do is try to have them in your system first. That is first step to become what? A very good student. So by studying, so you have to study. I look forward to see us again, and I look forward to the time where I will have a live practical class where I can carry out practicals. You see them and know what all these things I've said. You see how they play out. But all things being equal, it was a privilege being with you again today. I look forward to spend more time with you in the future. Do have a wonderful day, and I see you when I see you again.